topic, the life cycle of EV batteries. I will give a short introduction to today's webinar conditions to follow. So this webinar is recorded. Upon availability, we'll share these recordings afterwards. We do Q&A, question and answer after each speakers. You can post them here in the Q&A box. We only handle questions. We don't do any statements. There is a possibility to upvote these questions if you see a really popular question. And we also limit it in time, maximum 5 minutes or 5 questions. Participants will receive the link with the presentations if they are made available. So this webinar is, of course, developed with our speakers from other organizations. Nevertheless, views, findings, and publications of this webinar do not necessarily represent the views or policies of the AVERE or its individual participants. So thank you for that. I'm welcoming already the speakers for today. A short introduction from AVERE's side. AVERE, the European Association for Electromobility, is existing already since 1978. It seems a long time. We found the roots from an academic perspective, where our founders at that time were looking what alternatives can we give to oil run machines, transport, etc. Because the late 70s was a significant time for the world, because we had the first oil crisis, high demand and high prices. So today we have evolved indeed as an association towards more industry organized organizations, and we are happy to share that we besides have in Europe representatives from AVERE under national associations, but also direct members developing the European or assisting the European legislation and advocacy. So we have now also, due to that, 2,400 direct and indirect industry members, but also quite unique, over 100,000 EV users as member. And that brings us to the topic of today, the batteries. What is the situation of today in Europe? We have seen the last years a significant growth, especially in 2020. Nevertheless, that the COVID situation had a huge impact in the car industry. The EV industry was quite steady, and we closed off end of 2020 with pure electric vehicles above the 1,100,000. There is a lot of expectations for the coming years, so there is a lot of questions about the batteries and the full life cycle of the batteries, of course, the topic of today's webinar. So, one too fast. To focus on the battery, what we see specifically on Europe is that there is a plan from the European Commission to turn the EU into a contender in building batteries for electric vehicles and size market share from the dominant Asian producers in gaining traction. So the European Commission has approved 20 billion in spending on various projects, but now the focus is on securing raw materials and retraining workers to make the plan works. In total, we have 14 countries that are participating in the European Union battery push, which is driven by Brussels, Berlin, and Paris. And the result is that Europe should produce 7 to 8 million electric car batteries in the next 4 years. The risk now is, with the investment pouring in, the production will be undermined by a lack of trained labor and shortage of raw materials. And the focus on workers to build this battery production is quite key to succeed. Of course, nevertheless, there was always a big question that production of electric vehicles would lose jobs, labor. Well, if we can shift this labor towards battery production, we solve already a big gap. The Alliance also aims to fill a 15 billion funding gap to secure raw materials, necessary, of course, to boost domestic cell production here in Europe, which is supported by the European Investment Bank, etc., etc. The violent challenge, which is also covered today in the webinar, is getting the European Union legislative machine to pass the Sustainable Batteries Regulation with new recycling and due diligence criteria for cells sold in the European community. That will help also ensure the local output that can not be undercut by foreign manufacturers not conforming to European standards. So with this introduction, I will shortly give you an overview of the speakers of today. And we are kicking off with Bert Witkamp, co-host of today's webinar. Bert, please, the floor is yours.
Thank you, Philippe. I will start sharing my screen.
Yeah. That's working.
Okay. I will first give a very short introduction of what Taskforce CRM4EV is. And at the end of the webinar, we'll give a small overview of some EV outlook. The disclaimer you've heard before. Taskforce is an initiative which is supported by the IEA Hybrid Electric Vehicle Technology Cooperation Program, which is an independent initiative started in 1993 and which at this moment, where at this moment 19 different countries participate. If you look at this map, I would say by heart this represents maybe 95% of the EVs which are being sold and which are on the road in the world at this moment. Task 18 started in April 2018. What is the mission? So it is really connecting the raw material industry with electromobility. As you know, there are two different worlds which, let's say before electric vehicles had very little to do with each other and which are now very much connected. The principal mission is to supply objective information to the Taskforce participants themselves and to the government policymakers. The IAHIV is mainly constitutes mainly of government representatives, which are either from government ministries or agencies or research national research organizations. So that's the main target group. But of course, like today's webinar, we will also do public information. And there's a lot of, the other objective is really to facilitate international collaboration, which we indeed see happening. Scope is raising awareness of the topic, and we do this through workshops, of course less today with the COVID-19 situation, webinars, and we are working on a publication on EV batteries. On this slide, you can see the participants, the actual participants. So of the 19 countries, 10 countries are actively participating. The two external, let's say Japan is also represented and Western Australia. Good opportunity to say that tomorrow we again have a webinar, and that is organized by Western Australia, and that gives a unique opportunity to have some real good insights in what is Western Australia about concerning electric vehicle, a lot about mining industry, but also other activities. Government agencies like Geological Survey, Research Institute, Office of Low Emission Vehicles in the UK. Research is very good represented, and what is unique to this task is that also the industry is represented through several mining companies and metal institutes, and also some other companies like Umicore. This is the last slide for the introduction. It's so what it is about. It is looking at the two ends of the supply chain mainly. Electric vehicles, of course. What do we see happening today? What do we think might happen tomorrow? We work on scenarios. We're not predicting futures, but we work on scenarios, and we evaluate and analyze other external scenarios. And it's all focused about mass deployment of electric mobility. So what will that mean to especially critical material or potentially critical raw materials? That is from a physical supply point of view, but we also look at environmental impacts, social impacts, and of course, very importantly, and today focus area, recycling. That is it for the introduction. So Philippe, I hand back over to you.
Thank you, Bert. Thank you for this introduction. I think we can go immediately to Mr. Lin. Welcome on today's webinar. I'm happy to have you here. I think you can kick off immediately with your presentation. Mr. Lin is the CEO of Botree, but he will definitely introduce himself.
Thank you, Philippe.
And I can confirm that we see your presentation.
Okay, it works now?
Yeah.
Okay, can I begin now?
Absolutely, go ahead.
Okay, thank you. So good morning to the friends in Europe, and now we are in the afternoon in China. So I will share some of our experience and our work in the power battery recycling insights for the whole life cycle for the EV battery. So this is a disclaimer. So Botree is working for the resource regeneration. So we work for the raw materials from the refining and also for the spent battery for the recycling. So we are working for the solution for the critical raw materials for the supply and also for the environmental and other safety risk. So that is what we are working. So we are provide full solution for from refining and the regeneration. So we think they have a lot of the similarities in the two parts, and they also have a lot of the difference. So we provide like the consulting and also for the technology service, and we provide equipment and the operation, on-site operation, and also for the offline operation technology service support. We are now focused on the developing the new and novel technology and processes to support a sustainable battery metal supply chain. So now we are facing for the keeping changing for the feed. So we now have the everyday changing for the battery materials and also for the battery design. So this is very difficult for us to design a stable process for the changing spent battery. And we also need to make a new battery materials that they can back and close loop to the supply chain. So this is mean we are now working for the materials regeneration. They are not only for the waste management. So this is what I will share in today's presentation. So the first part, we will take a very brief overview for the new energy vehicles and for the lithium-ion battery industry all over the world and also in China, in the East Asia. So we can find before 2018, China is the fastest market. They increasing very fast, but in the past 2 years, like the European countries, they increase faster than China, and they have more investment in the new energy vehicles industry. So now in China, the new energy vehicles, the share is around 5%, and this is not a big. This is not a lot more than the world's average level. And we can see in the European countries like Norway, Sweden, and also for other countries, they increased very fast. So in the past 2 years, so some of the countries now is over 20%. So now we can have a comparison. So, but China is still the biggest single country for the electric vehicles, because we have the biggest vehicles market. So in the last year, the Chinese power battery market, so the CATL is still the #1, and also for the #1 for all over the world. So we can see this is like BYD and the CATL, this is all private owned company in China. So like the CALB is a state owned company. We can also find LG Chem and Panasonic, and also the Guoxuan is last year is purchased by Volkswagen. So we can see the 3 companies as a foreign company. So they have a lot of foreign capital inside. Actually, they are also manufacturing in China. So we can find in the first group, they have different companies in these fields, and the CATL is still the #1. And in the last year, this is a lot of change in the background. So we think the biggest change is the Chinese government announced the carbon dioxide emission, and also for the carbon neutral in the way we call the 13-16 plan. So this is the very strong support for the electric vehicles, and also for other like the hydrogen vehicles. And we can find in the European countries, they will get around 19% reduction for the 2050. In China, the government announced there will be over 20% for the new energy vehicles. So we can find the different government, they have different attention the points. Then we can find this is also many difference for the regulation. So the last December, we can find the cloud will be shown. So the battery regulation afterwards. So we just share some of the Chinese one. So in last year, this is a draft for comments. This is also a regulation for the lithium battery recycling, but most of them is focused on the pollution control. So like in the hydro and the pyro process, and also in the dismantling, shredding, recycling stage. So this is not a big picture and not for the whole supply chain. It's only for the recycling path. The path 2 is we are taking a lot of attention for the emerging market in China. So some of the new trades is different from other countries in all the world. So we found like the battery materials, it changed a lot. So people still working a lot, take a lot of attention like the energy density. But in the last year, more people and more company takes a lot of time and spend a lot of investment for the safety. Because in the past 2 years, we have found a lot of safety issues in the electric vehicles usage, especially for the high energy density. So sometimes the companies should take a trade-off for the two very important issues. So we can find last year, the LFP in China is increasing again. So it's around 40% in the last year's electric vehicles battery. So compared to the 2019, it's around 32%. So I think last year it's around 39%. So like the LMO, and we can find a lot of companies like the NEO, they announced that they will get a solid state battery in the electric vehicles after 2 years. So people are more focused on in energy density and the safety together. So we can also find the changes in the battery design. So CATL announced the CTP, the pack, the battery pack, and also the BYD announced the blade battery. And this year, and we think the blade battery is announced very safe because they use a lot of the LFP inside and also have a lot of the new design. And this year, the Maxim battery, actually, they have a more safety in the higher energy density. In this Monday, in the Volkswagen's Power Day, they announced they will have over 18% for the unified cell, and they will have less speculative cell. So we think this is very good for the recycling, because now this is a very big problem for the recycling path. So for the dismantling and the shredding, we have to face kinds of different pack, module, and cell. And this is a new another change for we have introduced. So like Didi and other companies, they will own a lot of electric vehicles. There is very different from the last 10 years. So like Tesla. So I think last year Tesla began his taxi service in New York City, but most of the Tesla, I think over 99%, is sold to the individuals. So after Didi announced that they will be purchase 1 billion electric vehicles in next 4 years, so it will be means the electric vehicles spend battery connection system will be not so important as before, because the companies, they own the battery by themselves, they can recycle by themselves. So the recycle and the use for the battery can be occurred in one single company. So that also happening like the battery swap. So last year, CATL and other companies, they have used the battery swap technology in some of the mining companies. So in the heavy truck. So they use a lot of the battery in the rural countries. So it means they also own the battery by themselves. They didn't sell the battery together with the electric vehicles to the customers. So they didn't need to connect the battery again from customers. They just to replace the battery from a new one, so they can get the spent battery and recycle by themselves. Also for the NEO, and also for some of the sharing, the sharing bikes, and also for the e-bikes. And this is another interesting brand in the electric vehicles model we will introduce that happens in China. So like the Wulin Mini EV, this electric vehicles model just go to market in last August. In 5 months, it began the #2 in China. So the #1 is Tesla Model 3 and became the #3 in all the world's sales. So now in this year, in the past 2 months, is now the #1 owned in the world. So this is a very small and mini electric vehicles, and they will be very cheap. It's around €5,000. It's around that. So the price is very cheap. So you can imagine the battery they used is not so perfect as the Tesla and the Volkswagen they did. So it means the battery replace or the battery recycling maybe occurs faster than we estimated in the other electric vehicles models. So we can also find this is very, very big amount for the electrical bicycles in China. So this is over 350 million in China. So all the electrical bikes, they use the lead battery before. But in the last year, after the new Chinese standards and the regulation released, all this battery, I think not all, so maybe over 90%, because the new regulation asked that all the electric bicycles should be less than 15.5 kilograms. So it means if they want to drive farther, they have to use the lithium-ion battery. So this new market use a lot of the power battery, and in the electrical bicycles markets, they will have 3 or 2 years they need to recycle for them. And we also found the energy storage. They are also connect to the electric vehicles directly from, so like also by the battery. So we can find the information from the CATL's website. So you can find from the solar and for the wind energy, they will be used a lot of battery for the energy storage. And then they will be go to a V2X system. They can directly go to get the electricity from the solar and to the vehicles. So this means they have more batteries in one single place. They also have a big amount they will be didn't need, and it depends on the connection system. They can directly go to recycle or to replace or to reuse. So in this faster changing market, this is what we are working for, and some of our experience we would like to share with us audience. So actually, our team is experienced. We have expertise in these fields. We have the main authors for the Blue Book for the power battery in China, and also for the White Book for the spent battery recycling technology and industry, and also involved in some of the national standards and the regulation related to the spent battery recycling. So now we have the research center in the Suzhou near Shanghai city, and also have a carbon neutral research center in Beijing. So we have the test platform for our clients. They can send their spent battery to us. We can use our 1,000 hours continuous operation test platform for them. We can to dismantling them and shredding them, and then we will use the solvent extraction to separate and purificate for the nickel, cobalt, lithium, manganese to different kind of the battery grade raw material and source, and then we can make the source back to like the cathode precursors and other battery materials, and then came back to the supply chain. So based on our research platform, we provide the design and the consulting for our corporate companies. We can provide from end-to-end technology solution. So this is mean you just to send the spent battery, so we can get and analyze for the metals inside and different kind of materials, structures, and then we will be design and develop a process for our corporate companies the best way to get all this metal out and then back to a new kind of battery. So it means we can get a spent battery in 5 years before, and then to a new battery in nowadays. So you can imagine, so in the past five years, the energy density have increased 3 or 5 times. So it means you can get a spent battery to increase again for the 5 times for the energy density, and they can back use to the supply chain. So go to the design, and for the convention plans, we need for the requirement and the process demand from our corporate companies, and we will make the different options for our corporate companies. They can choose the best way, best process for them, because in different countries, different regions, they may have different permits. So like in different countries in Europe, like the thermal permits, they have some of them need to 3 years, some countries maybe need 5 years for the thermal permit. Then we have to choose another process for the treatment. And when we set down all the process, we will design for the engineering. We will get to a whole solution and the standards for the equipment and also for the warehouse. And then we will be provided the on-site installation and also for the operation, because we get the keeping changing battery in last 5 years, and we think we will also facing the keeping change battery in the next 5 years. It means in the next 10 years, all the battery recycling feed for the spent battery also will be keeping change. and we will use the keeping change battery design for the structure and also for the battery materials. We will make them to a new kind of battery materials. So this is the two end is keeping change. So we will provide the continuous technology service for our designed convention plans. So this is now we are design and we recommend for novel process compared to the traditional ones. We can get the higher capacity and higher safety, and for the more purified products. So in the first stage for the dismantling, so we can get a shorter process. We can get the copper and the black powder, and also for the shell for the separate, we can get the more nickel, cobalt, and lithium inside for the recovery, and we can reject for the major impurities. So from the foreigns, so like the copper and Environmen, there will be less in the black powder. After otherwise, if the copper go into the next stage, there will have a higher cost in the hydro process. So in the hydro process, we have another innovation for the separation system, because we have now a new our separation system. They can get the nickel first and then cobalt, and then for the manganese, there is much better for the high nickel battery. Compared to the traditional ones, they get the cobalt first and then last for the nickel. This is a very perfect solution for the LCO battery. So for the like the cell phone and also for the laptop battery, it's very good because they only have cobalt inside. So we just get the cobalt outside and purify them. It will be okay. But going to the NCM and NCA battery is not good for the new kind of battery because they have much higher nickel inside. When you get the cobalt outside, so you need to get the manganese first, because manganese is less expensive, and this is much more nickel, and nickel will be in the last. So make the whole process, as we showed in the left side, the whole process is very long. It will take a lot of the investment and also for the higher cost. So in our new recommend process, we can make the whole process 1/3 shorter than compared to traditional ones, and also for the lower cost in the operation, and also for the much cheaper for the investment. So based on our design for the engineering design and also our research for the process, we design for the equipment from the dismantling to the solvent extraction. This is what we did in last year. So this is container design equipment. So it can trade around 2,000 tons per year for the capacity. So it's already operated over 5 months already. So we have now 2 container design equipment in 3. They have moved in different factories. So now we are ongoing for 3 projects, convention plans. So the biggest one is not in China. So there is outside China. So it's a big one. So from pack to materials regeneration. And now we also like the hydro process and the dismantling process in different places in China. So we also trade different kinds of the battery. So we found not only for the electric vehicles, it's also for, as we mentioned, for the energy storage. So then we will go to a carbon neutral for the final goal. So we are not only design for the recycling and the refining, and we would like to together cooperate with people in the regeneration native design lithium-ion battery. Then we can get a more sustainable supply chain. We get battery that will be easy for dismantling, and will be the materials easy for regeneration. So this is what our company in the Botree Cycling goal. So we also invite people to connect, and we can have more discussion for how to build a regeneration system for the whole supply chain from Europe and also in the East Asia. Okay, That's all. Thank you.
Thank you very much. I have quite some questions coming in the Q&A book, so I hope you can handle all of them. Let's start with the first one. What are the efforts in China for battery design, for recycling or product labeling to help recycling the batteries?
Okay, I found the question from Christian. Yes,
Yes.
actually, the battery design is also going as we showed in the blade and also for the CTP. So because but we think most of their battery design is not for design for battery. They are designed to have a higher energy density and also for better safety. So we are also working with some of the companies in the design for recycling, but we still lack of the enough data. I think this is a problem for everywhere in the world and also for the whole supply chain, because now still not enough of the battery is go into the recycling stage. So we are now recycling for some of the battery. They will be used in 3 or 5 years before, but we didn't get the real time data because we didn't have the tester for the new design battery. So this is also we would like to invite, if anyone interested in these fields, we can have more cooperation for that.
Thank you. Next question from Oscar Yerm. What are the automobile manufacturers' motives for in-house cooperating outsource to recycling operations?
Yes, this is also another good question. Actually, in China, in our directives, we recommend the automobile manufacturer, like the OEMs, they will take the charge for the recycling, especially for the spent battery recycling. But we didn't find this is taking important enough role for the OEMs, because I think this is also difficult for them because they didn't familiar with the manufacturing for the battery and they didn't familiar with the battery materials. So we found like the Volkswagen, BMW, and Daimler, they are doing a lot of research in the battery fields. So I think maybe some of the European companies have more motivation for the recycling, because we found in the EU battery regulations, the EPR requirement ask the OEMs to require for the recycling. But in China, so we also contact with a lot of people, but we didn't find the automobile manufacturer they recycle by themselves. They also have cooperating companies, and also they can sell some of the battery to the recyclers. So they make a lot of the outsourcing. Yeah. So I think this question is also connect to the first one. So if we can get a better design for recycling for the battery, that will be easy for the OEMs. They can recycle by themselves. Thank you.
And the next question, going to all the sustainable battery efforts, when is the soonest we will see a reduction in mining of critical raw materials, especially when the transition to e-mobility opened up a path of profits for those in the segment with little to no consideration for the environment?
Yes, this is a general and also very important question. So we also concerned in this question a lot. You know, China contribute over 19% for the cobalt refining, but nearly all the cobalt resource is from like Africa and also for the Australia. And we also import over 19% for the lithium raw materials from abroad. So this is also very important, not only in China, but also in Europe. So this is a lot of the critical raw materials will be consumed for the neutral matter. But this is why we think it's very important that we should to recycle the used batteries because it's already going to our human beings society. So they can, if we can recycle them, they can reduce the raw materials from the nature. But if the new energy mix keeping changing and keeping increasing, so we think we have to consume more raw materials from the nature. But we can try another different way. That is like a lot of companies, they take the investment in the laterite in the Indonesia for the red mud nickel, and also in the Indonesia and the Philippines. So we can try some easy mining, and they have the larger amount for the raw materials. They maybe will be better for we can get some very real, and in some of people they couldn't provide the responsible minings.
Thank you.
Thank you.
Two questions which actually really connected to each other. So maybe you can handle as one. First one is more second life means less recycled raw material and so more and more mining. What is the breaking point decision between recycling to get back to raw material or creating a second life? And then the other question, which is very linked in my opinion,
yeah.
What point will recycled batteries be cheaper than new batteries? I know also from the industry perspective, depending which manufacturer you talk, there is the two opinions: preferable recycling immediately and go for the option for the raw materials, and of course the option from second life. How do you see that?
Yeah, I think this is a big question. I think maybe Bert can have a better explanation for that. So we know other colleagues in the CRM for EV, our Taskforce, they are working for this one. I remember some of the research results is in the 2035 there will be we hope there will be over 40% for the raw materials will be coming from the raw materials. Actually, in the new EU battery regulation, this is required. They have a very detailed requirement for over 2013. I think I didn't remember the exact numbers. It's around 40% from the recycled raw materials. But we also find from the energy storage and the electric vehicles market, if they will be keeping changing, they will be need more nickel, cobalt, and lithium. And we have to research for more energy density battery. They will be reduce their consumption for the raw materials. So thank you. Thank
you. In respect to keep the time, I will take the last answer. Specifically towards the Botree process that you have shown. So the Botree process results in an NCM precursor. Does that mean that the process should treat only one battery type and chemistry in order to get a defined NCM precursor composition?
Yeah, this is a good question. So I can take a few minutes for the explain. So we have the whole solution from the spent battery to the battery material like the precursors and the other materials. But because as we mentioned, the 4 projects we are designing now, they are all in the East Asia. So in the East Asia, they have a very comprehensive, very complete the supply chain. Sometimes the customers didn't ask us for the precursors because they have the precursors factories by themselves. They just need to get the battery grade nickel sulfate and also for the cobalt sulfate and for the carbonate lithium carbonate. So there will be different, depends on the requirement by our cooperating companies. But we also provide the whole solution for that. So if we can get the battery grade surface from the nickel and the cobalt, they can make different kinds of the NCM and NCAs. So it happens a lot of time in the past 10 years in East Asia. Thank you.
Thank you. I think we have to conclude from here. Maybe you can answer written the still unanswered questions where possible. but we have our next speaker on the agenda. So, Mr. Lin, thank you very much for your contribution of today.
Thank you.
And this brings us automatically to our next speaker, Mr. Stian Matsus. Welcome. You can start.
Okay, thank you.
Great.
Thank you, Philip. So I'll just share my screen.
Yes, go ahead. The floor is yours.
Thank you. So do you see the screen?
Absolutely. Go ahead.
Yes. First of all, very happy to be here, and thanks for the invitation from Bert, and also thanks to Dr. Lin for a very interesting presentation. We'll switch the focus now a little bit in this presentation to a little bit more Europe focused, and maybe to an area that is not so much discussed when it comes to recycling, and that's more on the anode side and the graphite. So I'll give a little bit introduction on the anode materials and sustainability of this production. Talk a little bit about what Elkem is doing in this space, and then, of course, talk about recycling and potential for this of the anode graphite. So I'll just start.
The future is electric. The demand for battery materials will grow more than 10 times towards 2030. This requires a change, from dirty to clean, from emissions-intensive production to a truly green industrial revolution. To supply this in a sustainable way, the next generation of batteries and battery materials must be better, greener, and affordable. Herøya Industrial Park is one of the biggest industrial parks in Norway. Here, Elkem intends to establish the Northern Recharge Plant. Through an innovative production process and high degree of automation, we will efficiently produce competitive anode materials with high performance and reliable product quality. Electrification is a global megatrend across transport and stationary energy storage. We see great opportunities for specialized products.
The future is electric. Let's make it happen. With advanced high-performance battery materials with a green footprint from Elkem.
Yes. So just a short video introducing a little bit the project we are working on now, the Northern Recharge project, to set up active anode material production in Norway. Just very briefly on Elkem, it's a company with a long history, established in 1904. It's transformed from an innovative technology company with groundbreaking smelting technology to today's company, which is a leading manufacturer of sustainable advanced materials. We're listed on the Oslo Stock Exchange and we're a truly global footprint. The company operates in 3 divisions. It starts with very power-intensive production. We are fully integrated from raw materials, from quartz to silicon production. So this is one of the main areas. Silicon is also the raw material for silicones. And then we have the carbon division, where we have a lot of experience with synthetic graphite production. So Elkem is very used to supplying large-scale material solutions to demanding applications, and also, of course, to the OEMs and the automotive value chain. Elkem sees great opportunities in the lithium-ion battery value chain. So it's on battery cell materials, it's synthetic graphite that I'll talk about today. Elkem is also, of course, as a large silicon producers. We're doing R&D on silicon in the anode to combine with graphite. So I'll touch briefly on that as well. Then Elkem is in the market with many products for thermal management, especially of battery packs, protection of electronics and so on with silicone solutions. Today there are more than 1 million electric vehicles on the roads that have protection and thermal management of silicone solutions from Elkem. So this is a big area. Then Elkem has a lot of experience on pyrometallurgical and hydrometallurgical processes, and we are also involved in an R&D projects on recycling, and specifically looking at recycling of the anode graphite, which I'll come back to towards the end of the presentation. We have a lot of power-intensive industries. Graphite production, anode material production is very energy intensive. Elkem is using a lot of hydropower, clean hydropower, renewable. Our company has also invested heavily in energy recovery systems. So with the new energy recovery plant that's being set up at our Salten plant in northern part of Norway, we're capable of recycling around 900 gigawatt hours a year. So this is maybe roughly the annual energy consumption of one of these gigafactories. As we know, really there are extensive plans for establishment of battery cell manufacturing capacity in Europe. A lot going on, and this is increasing rapidly. Also in North America. So with plans, which are the pipeline projects that are fairly concrete, combined, we are looking at a total of about 1,000 gigawatt hours per year in battery cell capacity, combined Europe and North America. Considering that the anode material, the graphite, is a major part input in the lithium-ion battery cell. As a rule of thumb, it's roughly 1,000 tons of anode graphite per gigawatt hour. So this means that there will be an annual demand of around 1 million tons from European, North American markets of anode graphite. So this is a huge number, and it's basically a supply chain that is not in place today with local production. So today, the production of active anode materials of graphite is totally dominated by Asian-based companies, and especially a lot of the production is taking part in China. So we see that there is a great interest to also get localized production of these critical materials, and then thus avoiding a lot of transport and so on. I think the battery value chain needs to become more sustainable, and this especially has to change as this industry grows very rapidly. One of the major sources of CO2 equivalent emissions is from the production of active materials and components. It is often a lot of focus on the cathode sides, nickel, cobalt, and so on, but also the active anode materials. The graphite is a quite big contributor to the overall CO2 footprint, or can be. So when looking at synthetic anode graphite production, synthetic anode graphite is usually the technically preferred choice of material. This is today, to a large extent, or almost all production is taking place in these open type Atchison furnaces. It is difficult to really clean, so there are issues with sulfur emissions, it's dust emissions, pH, and so on. Then you're basically heating your material to very high temperatures in the core of these furnaces, so heating up to about 3,000 degrees centigrade. This is, of course, very energy intensive, and you have a lot of cover material around, so you're basically heating a lot more than just your product, which means that these processes are generally have a very high specific energy consumption. So this can easily amount to 15 kilowatt hours per kilogram of product. That is more than primary aluminum production. When you couple this with a lot of the production as it is today is located in areas where the carbon intensity in the electricity mix is quite high. So this leaves a quite substantial CO2 footprint also. Can easily be well above 10 kg of CO2 per kilogram of product. So this is a substantial contributor. So this is what we are looking at kind of attacking with a more closed system where there is much higher energy efficiency, so we can reduce the specific energy consumption, and then also using renewable hydropower to power these energy-hungry processes. So just going a little bit into the battery cell, consisting of the four components: the anode, the cathode, the electrolyte, and the separator. Where the anode, which is today predominantly graphite, the task of the graphite is to store the lithium when the battery is in a charged state. And then the lithium leaves the graphite structure when you use electricity from the battery. The anode graphite is typically a fine black powder, 10 to 20 micrometer in size. It doesn't look that exciting, but it's actually a very highly engineered advanced material. The anode material, the graphite, will have direct influence on the energy density, how far you can drive on your battery when you're charged. It's about charging speed, which graphite is really determining how fast you can charge your battery. It will have an influence of how many, the performance over cycles, how many cycles you can charge and discharge the battery is also dependent on the graphite. And it's also important safety considerations that you need controlled and limited degradation mechanisms through many charge-discharge cycles, and also limited swelling and gassing and so on. So important safety aspects also with this critical material. So what we are doing here is implementing production where it's an integrated production from raw material to finished anode material, located in the southern part of Norway with good logistics, efficient logistics to Europe, international markets. Hydropower is used in the production, and also a high degree of automation. We think that there is a lot of improvement potential in how you produce these materials, make it more efficient. And of course, automation is critical to get this feasible in Norway. And automating processes also has important quality aspects. The anode graphite is coming in the Elkem bag here, is then mixed with binder additives in the cell manufacturing plant to make it into a kind of thick paint slurry, which is applied thinly on the copper current collector foil. It's then dried, densified, and then layered with separator and cathode. Of course, these processes are going at an incredible speed in the extreme volumes in the cell manufacturing plants. So getting this process under control is extremely important, not creating waste, not having to stop the production, and having stable input raw materials are really critical for this to reduce waste through this process. The cells are then encapsulated, and the battery cells are then, of course, assembled into modules, packs, for instance, integration in a vehicle. And then on the recycling, when this comes to end of life, we think that it's very important also to look seriously on the anode graphite recycling, because this will be such high volumes in the future. And we have put a lot of energy and effort into producing these kind of fantastic, highly engineered materials. So it makes sense to also look at recycling here. I think just on the demand for the product, just to touch upon that briefly. We're now industrializing families of products that are hitting different segments. But basically, there is some degree of trade-off between capacity, energy density, and power or fast charge capabilities. So here it's grouped in to the upper left with families with a little bit higher energy density and more power materials to the right-hand side, and then more balanced products in the middle. We do see a great interest now and increasing demand, especially for graphites or anode materials that can support fast charge. And with these balanced products that we are now launching, we see that we can charge at 3C rate up to at least 50% state of charge. Just as an illustrating example, what this would mean is that if you have a 75 kilowatt-hour battery giving your vehicle a 500-kilometer range, you can basically charge this without the graphite limiting it at 225 kilowatt, which means that you can charge up to 250 kilometers in 10 minutes, which is pretty fast. So this is really attacking the issue of the graphite being the limiting factor in high charge rate, high speed charging. The issue is if you try to put too much lithium into the graphite structure at a too fast rate, it may start kind of plating, or you can build up lithium outside the graphite particles, and this will lead to irreversible damage to the battery and may create very dangerous situations. So this, of course, you want to avoid. And thus it's a big focus on getting materials that can withstand higher charge rates and at the same time maintain a good energy density. Also, when you put all the effort into making these batteries, they should really last. Synthetic graphite in this respect is very good. We have an example here on the right-hand side where we cycled at 1C rate with an NMC cathode. 1C is quite fast here, and charge this to 2,800 cycles and retaining a little bit less than above 75% of the original capacity. So this really lasts for a long time. This battery would then last you for well above 1 million kilometers. So that was a little bit about the criticality of the products and the product itself. What we are doing now in Elkem, we have a pilot where we're scaling up products, fine-tuning, and sending out qualifications. We're investing about $10 million US in an industrial pilot currently. It's partial operation. This will be to produce material in full-size industrial equipment, do qualifications and so on, train operations personnel. The pilot will be fully operational from April. So it's in final construction and commissioning now. Then at the same time, in parallel here, we are planning a large-scale production plant with capacity up to 50,000 tons per year in southern part of Norway, the Northern Recharge plant. So 50,000 tons, that's roughly 50 gigawatt hours, or roughly enough for maybe 700,000 personal vehicles a year. So it's fairly big scale, but looking at the needs that are coming in Europe and North America, this is there's still big needs. So we're here planning startup production in 2023. So here is just an image of the site and a sketch of how the plant can look like. It's located in the southern part of Norway between Oslo and Kristiansand, with very good logistics to the continent and international markets. think also briefly mention silicon. Silicon has the potential to, it can basically store much more lithium than graphite per weight. So it makes it then a good choice for increasing especially energy density. And you can basically boost the capacity by adding some silicon into the anode mix. However, the technical or a little bit fundamental issue is that silicon is cracking. It's expanding a lot and cracking during cycling. So there's still R&D challenges to really make this viable for long-term cycling. But silicon is already used in small percentages, maybe up to 5%, in addition to graphite, to boost the capacity somewhat today in certain cell designs. Elkem is a large-scale manufacturer of silicon. We have a special sil grain product, which is produced in a very sustainable way in large scale in Norway, in our Bremanger plant. And this material, we've worked on this for quite a long time, and it's showing very promising performance in batteries. So this is also a focus area, and we are developing silicon graphite composites that can increase the energy density of the battery cells as next generation materials. Of course, mixing different kind of products in the anode brings me a little bit. It's a bridge to the final topic here, which is really recycling of graphite, and the kind of challenges of separating the materials and so on, which I'll come back to a little bit. Graphite is the dominant material now, and when looking at the cell manufacturing production process, there are many places where you may produce scrap. It could be scrap from the slurry mixing if you don't get things right, or there is some issues with the product quality or so. It can be scrap from graphite containing scrap from the electrodes. It can go all the way to the finished cell, and then it fails in the quality control. So then you have a full cell with graphite inside. And then, of course, the large volumes in the future will be from end-of-life batteries. Just looking a little bit on Europe here, of course, one of the sources here of graphite that's coming in over the next years here will definitely be graphite from that's coming from scrap production in the cell manufacturing plants. Of course, the scrap rates here are not really, that's not that available information. So we have here just made an example with an assumed scrap rate of around 10% from cell production. But I think what we hear is that especially during startup of these cell gigafactories and the ramp up, the scrap rates can for periods be quite a lot higher than this. But just an example, with the growth in the cell manufacturing capacity in Europe until 2030, and assuming 10% scrap, we'll probably be looking at above 50,000 tons of graphite available every year annually by 2030. So it's quite big volumes only from this side. And then, of course, as batteries come in, the end-of-life batteries and graphite from that will, of course, in the future play the major role. But it's a fairly minor contribution on this kind of 10-year perspective, but still around a little bit less than 10,000 tons than expected in 2030. So as activity, we are looking at the recycling of the graphite here, basically taking back graphite from end-of-life batteries or production scrap. It contains impurities, so we basically have a thermal process where we remove the impurities to form a very high purity level of 99 98.9%. Also in the thermal process, you're at least partially fixing defects in the graphite structure. You're kind of annealing it, where you had structural defects through the cycling and through the use of the battery. So then kind of purifying it, doing some modifications to particle size distributions and so on, and putting a new coating on it. And we are achieving very promising results by taking this recycled graphite back to new anode graphite. So this is really looking like it's technically feasible. I think here is just an illustration. I guess it would be a bit tedious to sit here and pull apart all these cylindrical cells. You'll have several thousand of them in one car battery. So that's a bit boring and it would take quite a lot of time, but just for illustrating purposes, kind of take away the graphite from the foil and kind of make it into a quite pure graphite that can be reprocessed and recycled. So one of these cells will contain maybe around 10 grams of pure graphite that we can take back. And here are just some examples of different kinds of graphite that could be found that has been recycled. It can be synthetic graphite, but also mixes with natural graphite. So I guess we should talk a little bit about there are some issues to be solved in a way or discussed when it comes to recycling of graphite. It's important here to that graphite is fundamentally different from the metals you'll find for recycling, like cobalt, nickel, copper from the foil, and lithium and so on, because you can't really have graphite in a solution or melt it. It will kind of remember its original structure, and really it doesn't melt. If you heat graphite to well above 3,500 degrees centigrade, it won't melt. It will just sublime or go straight into the gas phase. So we'll have some traceability issues here. You will kind of know what you put into the battery up front to have control. And this is of course an issue when you're kind of collecting a lot of batteries and shredding it and mixing batteries from different sources. So there is certainly a traceability issue that has to be addressed. Then it's mixing several graphite sources, often a little bit for various reasons, supply, costs, and so on. You're often mixing synthetic graphite with natural graphite in blends. And then you'll have two very distinct sources of graphite to deal with. Then, of course, on the recycling, it's a big technology time lag. So you'll also recycle materials that where you have a lot of technical development of the materials in the time until it should be reprocessed into new battery materials and go into new batteries. Then on the recycling, it's not only graphite in the anode. It's the binder phase and also some conductive additives like carbon black, for instance. So we would have to do some separation of that. And then it's also that you can introduce chemical damages in the separation stages. So you'll have some irreversible structural damages. So there are some questions here around cost, quality, and of course the performance versus virgin material. But we're getting very good, promising results from recycling. And maybe as a start, maybe you could look at least recycling parts of the stream back in. So you blend with virgin materials. Yes. I think I won't spend too much time on this because I think our next talker, Claude, will probably know much more about this than me and really give a much more in-depth look at this. But basically, the existing battery directive is no longer up to date and needs renewal. The proposal that was put forward in December really threefold in objectives. It's strengthening the function of the internal market, including products, waste batteries, and recyclates, by ensuring a really level playing field through a common set of rules. So that's one important thing here. Then it's, of course, promoting a circular economy. Recycling is very important here. We also believe it's necessary to look at the recycling of the anode side. And then, of course, reducing environmental and social impacts throughout all stages, from raw materials to finished products in the battery life cycle. So Elkem really wants to be at the forefront of this sustainable anode material production and also contribute to a greener battery value chain, and also looking here at recycling. So I think this serves as this slide as a handover to our next speaker, Claude, who will go much more in depth here. So thanks a lot for listening.
Thank you very much, Stian. Really valuable insights from the north of Europe. We have some questions here that came up. We'll see if we can address a few of them, and if not, we will keep the answers written. Sorry. What relative energy savings can be expected for secondary graphite production compared to primary graphite production? Do you have an idea on this?
I don't have a fixed number I can give here now, but there will certainly be. It's somewhat on the heat treatment and so on, where you don't have to go that high in temperature. So it's some reduction in the energy consumption there. And then, of course, you've done a lot of the job up front because you already micronized it. You've shaped the material and so on. So those are also energy intensive processes. Yield loss and so on. So there will certainly be a reduction in the specific energy input, but it's difficult to give a specific number here.
Then on the fact that natural graphite could emit less CO2 than synthetic graphite due to the high energy use in electric furnaces, do you agree with this, or does Elkem have another life cycle analysis study that analyzes this?
This depends, of course, a lot about the carbon intensity in the electricity mix. So the major CO2 footprint here is from indirect emissions. So basically, if you have a clean energy source, the CO2 footprint of synthetic graphite is not really a big issue here. And there are also generally in the production of synthetic graphite higher yields and so on. So I think with more energy efficient processes and a clean energy mix, there's not really anything that would say that the synthetic has a higher CO2 footprint than natural. It could even be lower.
Okay, and then the last question that we will handle here live to respect our timing. Considering the potential issues mentioned, like traceability, damage to graphite during use phase, how realistic is to recycle the graphite back into a battery grade quality?
Yeah, no, it's of course issues. What we've seen by testing it is that it looks very promising. Maybe, as I mentioned last, that it could be a kind of intermediate solution where you're recycling, where you're mixing in parts of it. And it is all battery graphite materials to start with. So it has the properties and the general structure that it should have. So we think it can be feasible, and it may be necessary to put up more closed loops when you got into really big scales of this industry. If you could kind of separate the recycling from different cells where you have traceability through the value chain about what kind of materials you put in the first place, in a way, then you could have more control about this traceability.
Okay, thank you very much. Thank you for your contribution of today. And this brings me automatically to our last speaker from today, Claude Chanson from Recharge. Welcome, Claude.
Good morning, Philippe. Thank you very much. I hope you can hear me, see me.
Clearly.
Perfect. So I will share my screen. Find that one. Yes. All right. So my intent today is to talk about this question of impact of the new regulation on the circular economy. And indeed, we will see that the new regulation has a lot of high-level intentions and could, in fact, really have a strong impact on the circular economy and the actors, particularly the actors of recycling. So to start with, I will first show a short resume of who we are at Recharge. We are an association representing the advanced rechargeable and lithium batteries value chain in Europe. And we have been involved for years in all these three pillars, which are today at discussions with the new regulation, which concerns the question of environmental friendly design, manufacturing, and end of life, the safety of manufacturing, of usage, of transport as well for lithium batteries, and finally, the social responsibility of the company in the entire value chain. So this is very much aligned with what we see today in the new regulation. Our membership, I show briefly here, represent the full value chain, meaning we have a number of companies, including some very large companies producing materials, which have joined recently Recharge. We have companies that, of course, manufacture the battery. You see in the center circles that include the historical large European and non-European companies. And we have on the top, you can see a number of companies that are placing the batteries on the market, which have the so-called extended producer responsibility for batteries, including the end of life. And finally, companies which are recycling batteries on the right side. So now moving to the high-level targets we have, and we see it's indeed in this new regulation, we see an opportunity for the so-called industrial and social revolutions for a more empowered and sustainable society. The decarbonization of the society is associated to batteries, as you know. So we have here a strong expectation from the new regulation. We expect it to support our approach for competitiveness. And that's, of course, the first point for an industry associations, support competitiveness of the European battery ecosystem, which, as you know, is very weak when compared today to the production of other parts of the world. Talking about a new regulation was, again, what we expect as an industry is to have something which is lean and coherent, avoid over-regulation, avoid overlaps, and take into account an already significant regulation existing. We'll come back on this. And finally, what we consider is important is to consider the full value chain approach in a holistic approach of what is battery manufacturing. So starting with the mining and finishing with the recycling after second life of batteries. So that's what we are considering the three pillars we are really looking at in the new regulations to be supported and enhanced. And of course, this is in the framework of this new regulation to support environment and sustainability as well. Just a short, quick slide for people which are not so well aware that a lot of regulations are already applicable to batteries. We are looking at the today battery framework. You can see that there are applicable rules and regulations attached to the extraction and refining on the bottom left, which means indeed the local permits, the workers' protection wage, and already a due diligence as on the voluntary base is something which a number of our members have set for some years already. At the manufacturing level, then we have, of course, the batteries directive, which have some recommendations, as you know, the battery categories for placing on the market, and our existing regulations related to the REACH and OSH and so on. We see coming more and more ETS, which is a transversal regulation, which is a carbon border tax, which may quite directly impact the batteries manufacturing in Europe. We have a regulation about transport at the UN level. Batteries, lithium batteries particularly, are classified as dangerous goods for transport. Then they have to comply when shipped or stored. And finally, we have rules for the use and the end of life, particularly the batteries recycling targets, which have been set in the 2006 regulation. Sorry, it was a directive. So that's already a lot of things existing. So when we are assessing the new regulation, we have been looking by let's say by difference, what was needed and what was useful to make this new regulation be efficient. So on the left side, you see a list of points where we believe indeed this is correctly implemented and we welcome the new regulation on these aspects. The first one, of course, is recognizing the strategic role of batteries and promoting the idea that it's important, it's strategic to have batteries manufacturing in Europe. We see a number of relevant updates, particularly when it's come to the market changes, the technology changes compared to the previous directive. And we welcome, for example, the new categories of EV batteries, batteries for electric vehicle, which in fact makes sense when you look at the new market structure in the coming years. The objective to create coherence is here, and that also is, of course, welcome, despite we will see that we believe it's not clear enough in this new proposal. We have emphasized here also in the fourth point the importance of having a regulation rather than a directive. And the reason is that we have experience in the past with the batteries directive, various interpretations from the member states when it comes, for example, to what is the statutes for some products you get at the recycling steps, like not black mass. Black mass is generally considered as still a waste, but you have slags of recycling that some countries consider as a recycled product and some others do not. So that's not helping the industry. And so a regulation in principle should avoid this kind of local states interpretation. And finally, we welcome very much some of the new criteria that are proposed to measure the sustainability or the environmental impact of the batteries. So the carbon footprint is a measure that we have been working on for years, particularly in the framework of the product environmental footprint, which is mentioned by the Commission in the new regulation as the base for calculating the carbon footprint. So that's a good point. Due diligence becoming a mandatory declaration of your efforts in due diligence is also considered as a good progress forward, competitiveness based on sustainability aspects, as well as battery passport, which is good for transparency, communication, and green public procurement as well. So that's a number of good points, which indeed give to this ambitious regulation a good base and a good focus. Nevertheless, on the right side, you see there are still a number of points we believe need serious review or improvement. Some basic statement is the point one. It has to be feasible from the timeline point of view. You have seen in the presentation of Stian a few minutes ago, there is a long roadmap of implementation, but not all dates are very coherent. For example, we believe that the setup of the carbon footprint declaration may be very early compared to the time needed to set up the complex rules for this calculation. And that's just an example. The second point is we are not very confident that the enforcement and the level playing field will be ensured. It is, of course, recognized that there are some efforts and some articles directly dealing or aiming at this, but we see significant gaps. I will come back on this. We have a general concern, and this third point here, about the safety of lithium batteries particularly. As you know, lithium batteries are today safe thanks to a number and relatively complex combination of measures that include the safety design at the cell and battery level, but also, of course, the fit of the functionality safety with the application, the role of the electronics, the BMS protections, and so on and so forth. So it's a multiple layers that is sometimes we worry may not be respected when we see the welcome intention of remanufacturing batteries or recycling batteries. We welcome the intention, but we worry that the way it is proposed is just overlooking the safety hazards. And that may be very harmful for the industry if you start having issues, safety issues with batteries coming from second-hand use or repurposing. So that's really a concern. Then we consider there is more work to do to harmonize with the batteries regulation inside and with other frameworks. Inside there are some overlaps, and I can give some examples later on this. And with other frameworks, more important example we can excuse me, we can highlight is, for example, the REACH regulation paragraph, which is introduced inside the batteries regulation. We have then to think about reducing the complexity by focusing on real benefit provisions. We see that there are already important provisions like the carbon footprint and others, but there are many, too many proposals, and someone where we see are either overlapping, like, for example, the performance requirements for industrial batteries, which from our point of view make no real sense because industrial batteries have performance requirements by their OEM customers anyway. So there will be no need of, for example, the Article 10. Also the recycled content, which I know it's a highly debatable question in recharge due to our, let's say, full value chain representation. We have been able to discuss this more in detail and identifying really that the recycled content, meaning a mandatory minimum content of secondary material, is, as was presented in the impact assessment of the Commission, not really bringing significant impact, and particularly because of the reduced feasibility nowadays, as was presented before, as you have seen, for the moment, the manufacturing production increase far exceeds what you can get from recycling. So it's really difficult to provide regulations asking for more than 5% or 10% of secondary materials, which is therefore not very efficient. And finally, we believe that there are a number of requirements that should be simplified, particularly for small battery series, small industrial niche markets, and others. So to come more to specific points, when we talk about timelines, I would like here to highlight, for example, first of all, the need to have a transition period and grandfather clause, which clarify when the new regulation is applicable and when the earlier regulation, because we see significant changes, will not be applicable anymore. So there is here a need to clarify these aspects. I did mention the carbon footprint for the implementation of the new rules at the same time of the regulation becomes applicable. So we need here the time to adjust. And when it comes, for example, for recycling and end of life, it's clear that if there are declaration and requirements of new recycling efficiency, it's clear that for the recycling industry, we need, of course, to have time to adjust to the new rules after the new rules are been set up in order to become compliant if this represent any change in the processes. And that's really a risk we face today, where we see no real precautions were taken from this point of view. Second point is to have a higher level playing field and strengthen the enforcement. As you can see here, we are recalling that we have unfortunate experience of unfair practices. You can see here a link on the presentation to an article recently published, really demonstrated how far now the third-party auditing bodies practices in the field of standard, quality standard, you know, like ISO 9001 or such type of quality systems. So how far the unfair practices have gone, and particularly in China, which is really a concern if you consider that these would be applicable, for example, to the declarations of carbon footprint. So this is highlighted here, that some articles should be more clarified and provide, let's say, more power to the European authorities when batteries are imported, or as well, which is very important for the recyclers. You may have noted that in the new regulation, there is an Article 58 that is promising exactly the same thing that was promised in the Batteries Directive 2006. It says batteries can be exported for recycling in equivalent conditions. And we have nothing, of course, to say about this, but what we are worrying is that once again, we don't see any time reference or any description of what meaning of equivalent conditions. And unfortunately, we have got the experience that for the last 14 years, these so-called equivalent conditions were never written for the Batteries Directive. So we have concern here to say, well, if you are really willing to have a level playing field, these equivalent conditions have to be described, and the sooner the better. So that was for the enforcement of this level playing field aspect. Now, the safety, I did mention some word about this. When it comes more to the end of life, we believe, as I was mentioning, that the wording, for example, of the Article 59 about second life is not really preventing, and on the contrary, may be understood as pushing unqualified person to deal with this end of so-called first life batteries. You know, of course, that a lot of potential value is attached to batteries after their usage in an electric vehicle. We are willing to support a clear business made on these batteries. It was discussed this morning, for example, that the car manufacturer may themselves be willing to take on board this potential additive business, which is perfectly fine with us. But you know, the Commission is promoting this in a broader way and saying anybody could become a remanufacturer. I mean, this is legally funded or meaningful, but from the quality and the safety point of view, this is certainly not acceptable. We worry really that this regulation is pushing unqualified persons to unduly take and modify batteries. Fourth point here is about the overlap with other regulations. I did quickly mention that. You have seen that there is a strong part of the battery regulation which is dedicated, Article 6 and 71, to chemical management. And we understand, of course, that the chemical management of the could be improved. And by the way, we appreciate the proposal of the Commission's, which is mentioning to have a risk management approach, so a risk-based approach rather than a hazard-based, which is strongly supported by the industry in general. But in fact, if this management of chemical substances should be made, it should be made in the REACH regulation, because that's what is really the regulation for the management of substances. So we don't criticize the content of the proposal of the Commission, but the real principle to add chemicals management specific to a product. And you can imagine today we have the batteries under scrutiny, but why not today have, I don't know, the chemical management specific rules for the hydrogen energy or for the ICT components? I mean, there are a number of critical type of category of products to support European development that may face the same situation. And we believe this would not be, in fact, feasible after some point. Within the battery regulation, we have, concerning the end-of-life management, the proposal to improve the circularity of the economy of batteries, so increase the circular economy, thanks to measures that could drive more recycling by calling for the recycled content. I did already mention this, we believe, is not really helpful. It's too stringent and risk blocking the market. And also on the collection aspect, we believe that the way the batteries are collected should change rules, as well as the way we calculate recycling efficiency. To be very clear here, this recycling efficiency, you may know, at the batteries industry is measured by comparing what's going out of the recycling process compared to what's going inside the recycling process. And this is called the mass recycling efficiency. And this is really specific to batteries. And when you compare this to WE and ELV, they are working on different concepts. And we believe that the batteries should be harmonized with this, knowing that the battery materials recovery will be in addition in complementary targets. So now to conclude quite quickly, we have a number of simplification also to harmonize and simplify. A number of information about marking, labeling, declaration are certainly not harmonized. We need here to harmonize and digitize. If you just look, for example, at the annex, which is describing the list of information that the label should contain, the label on the battery, it's only possible for a large battery with a very large label to put all the information required. So it doesn't make sense for a number of batteries. And we believe at the time where information should be digitized, there should be harmonization and reorganization here to get a better benefit of the batteries passport and less use the old style labels information. Then coming close to the end, here we have a more specific discussion about the Article 8, which I mentioned already several times about the end of recycling requirements. Well, the global point here, as I mentioned, was that anyway, due to the limited amount of recycled batteries coming compared to the batteries that are manufactured due to the market growth, this is limited by nature. There is no way to have high level of recycling here content. So our approach here is to propose, first of all, to move to a voluntary base for this recycled content, which is of course possible to do. But we believe here we can certainly work with the recycling industry. That would be helpful for the recycling industry as well on the end of recycling criteria. And driving the quality at the recycling step by a description of what means quality of recycling. And here we have proposal that we will discuss within Recharge and other groups like with Eurometal and other industry to make really strong progress in defining what means recycling quality, avoiding, you know, the well-known downcyclings and other questions which are generally bothering our political partners, in order to make sure that the end of life is correctly treated, and then avoiding these requirements on the new batteries design. Second life, I did mention the safety risk here already about the approach for safety. I have here to add also the question of intellectual properties, where we believe that a number of requirements about the BMS, battery management, are certainly infringing some intellectual property rights when it's come to the transfer of data to any second life user. Collection of waste portable batteries, we already discussed it briefly. What we propose here is to move to a new way of calculating available for collection, and this is a very general industry approach. You know that the Federation of the European Collection and Recycling Organization is promoting this concept of available for collection instead of what was placed on the market in the last 3 years. And indeed, this concept is becoming more and more let's say, representative of the new reality. And we know that, by the way, the Commission has already started looking at it with the GRC. So that means that the new rules associated with these collection targets may change indeed compared to the annex which is proposed today. Then to finish, and I understand I'm a bit late, so I'm concluding now, this reduction of complexity. Sometimes you can see here the scope of the measures is too large compared to the initial intent, and including sources, small niche and small series batteries, where all the applicable regulations applicable to the large volumes manufacturing, like electric vehicle batteries, are certainly disproportionate burden for these small series or SMEs companies. Also, we see, for example, Article 14 is a bit funny because it's requiring BMS obligations, for example, for technology that don't have a BMS. So I don't see how we could apply this. These are just examples that we could simplify and reduce the complexity of the applicability of the batteries regulation. And I'm sorry I took a bit more time, but there was so many information in this new regulation I wanted to share with you. So I tried to go through a number of this content. Thank you for your attention.
Thank you very much, Claude. Thank you for sharing your insights. I have a few questions. I think we have to keep it short to not run out too much of time, indeed. I will kick off with the first one. How can we make battery manufacturers responsible for putting recycling technology and plans in place along the development of their cells?
Oh, sorry, I'm not sure. As you said, the question is quite long. I'm not sure I capture really the intent.
If you're not sure, feel free we can skip it, of course, as well.
No, this just well, I was not reading the text you are mentioning, so I am not sure I really understood the question. Sorry.
So how we make battery manufacturers responsible for putting recycling technology and plans in place along the development of their cells. So the question is actually, yeah, you can produce whatever you want, but how we make them also responsible from...
Yeah, you know, the fundamental principle is that indeed the existing regulation as well as the new regulation is clearly putting the producer responsibility in the hand of the battery manufacturers. So it means that when you produce a battery, and then of course you select the design, you select and you are responsible for the environmental impact of what you do during manufacturing, you are also responsible of setting up a method that will comply with the new regulation when it's come to the end of life. So this question of recycling and potentially reaching the targets of recycling is in fact under the responsibility of the batteries manufacturer. So we know that from these mechanisms today, these questions of design for recycling or taking into account the consequences of what is placed on the market when it comes at the end of life is ultimately under the manufacturer responsibility due to the legal structure of the regulation.
But last question. When used battery will be recycled, when in the process does it turn into waste? For example, already at consumer, after removed or after receiving in a dismantled plant?
Well, once again, I'm not so sure about what the question means.
Yeah.
We can say that indeed we have this new concept of second life of battery, reuse of batteries, but it's really attached to large batteries like electric vehicle. All the rest, and we don't see anything new in the new regulation, is indeed already intended in the existing directive. Maybe it will be improved with the new regulation, but it's already intended. And particularly the questions of the need for the waste managing or the waste treating organizations that receive, for example, WEEE or electric vehicle or vehicles in general, they have indeed to separate the batteries and then the batteries for the batteries recycling operation. That's already the rule today. We may say that maybe in the future it's become more difficult. Well, it's not sure. Maybe yes, maybe no. What we see is more and more products. For example, take the power tools. Power tools is today recognized the type of equipment where you have a swappable battery. You have, for example, one battery for 2 or 3 tools. And it's clear that when the collection of these products at the end of life contain a battery, this battery will be removed and treated into the battery operation. It's also true for other type of equipment like the vehicles, for example, and so on. We can, on one side, forecast some batteries will be certainly integrated in the equipment and maybe requiring then more automation to separate the batteries. But some others are becoming, in fact, more removable. So that's and that's already the case, of course, for primary sales, for consumer applications where they are very well regulated from the point of view of removability. So all of these, I would say, is not really innovative in the new regulation. What's just changing is our world of products and type of products, but the very concept behind it, that batteries have to go for recycling in a battery recycling process, is already in the regulation.
Good. Thank you very much. Thank you for your insights and your contribution of today. I will hand over the word to Bert Witkamp to make the conclusion of today's webinar. Thank you for all the speakers of today. Bert, if you could start sharing your screen.
I'll start sharing the screen. I have some few slides on some key developments on EV deployment and outlook, and I think 2 very disruptive developments over the last few months. This is just the numbers, which most of you will know. Of course, we look at the sales per year. So last year, 3.2 million electric vehicles, that is full electric and plug-in hybrid vehicles, have been sold globally. If you look at the last 5 years, the growth rate has been 45% per year. So that is quite impressive, but especially the last year is going very strong in Europe. This is the fleet. So we're now up to more than 10 million electric vehicles globally. This is very interesting picture in Europe. When we look at all the what they call alternative fuel car sales. So these are the new registrations in 2020 as a market share. So this is the percentage of sales of all these alternative fuel vehicles across the EU. So across the 27 countries. You see a few things, but what is clear is that electric vehicles are dominating the alternative fuel car sales by far. 5 years ago, electric vehicles was maybe 10% of the sales, or not even that. So that is a big change. What's also, you don't see that is in this picture, but what you see over the last few years, that the sales of electric vehicles has been very much spread over many European countries. So it's much more, let's say, democratic sales for all member states than it used to be only for a few countries. And if you look at the left-hand side, you look, there are already quite a number of countries who have had last year more than 10% of all new car sales being electric vehicles. And several countries are touching or have gone across the 20%, or even in Sweden, the 30% mark. So it's getting mainstream in many countries. This is analysis just updated for Task 40. So here we look at, I will not go in detail, but you will find this in your slide pack, either the Global Battery Alliance, so global scenarios, but mainly EU targets, the new Green Deal, Chinese targets, and of a few other countries. And they are translated in, because some some countries have a target on total electric vehicle sales, other countries on full electric vehicle sales. Other countries have still fleet targets to achieve, and still other countries have percentage targets. If you translate those all back to what does that mean for the increase per year, the requirement, so you see this column, and you compare that to what we saw the last 5 years, so the 45% per year, then it is not that, it does not look that big a challenge anymore. Whereas 1 or 2 years ago, we said these same targets, they are daydreaming. And so that is how fast it really is going. And I'm convinced if you look at, for example, the European target, 30 million full electric cars by 2030, which may seem a lot now. If you look what's really happening in Europe, I'm pretty sure this goes a lot faster than this, but time will tell. Last few slides, that is on a very interesting, let's say the Volkswagen Battery Day, following the footsteps of Tesla, which was held on Monday, which you can see again on YouTube. Some key messages, some key takeaways from that. One is the target of Volkswagen as a group in Europe. Last year, they had a target to sell 30% full electric vehicles by 2030. This year, so 1 year later, or less than a year later, this has doubled. So now Volkswagen aims at selling 60% of all their sales is full electric cars in Europe. Globally, this percentage is 50%, by the way, for Volkswagen. So Volkswagen alone estimates to have 6 battery plants, 40 gigawatt hour each required just for the sales in Europe. And so that's how far it goes, how fast it goes. What was very interesting, which was touched upon by earlier speakers, is what's happening in the batteries, battery design, but especially battery chemistry, which I want to focus on this slide. 1 or 2 years ago, again, and some of the scenarios I mentioned, they take for cars almost only nickel and high nickel manganese cobalt battery chemistries, which is what we call the NMC, or for Tesla, the NCA chemistries. What you already see happening in China, and which is coming already in some cars in Europe, that is using LFP So lithium iron phosphate also for regular cars, mid-sized cars, and even small luxury cars, like in China, the Tesla Model 3. What is clear now in the Volkswagen strategy is that what they call the cost focus, so take the small cars, which is the very big market share of the cars, of course, that will be LFP focused technology. The interesting thing is, and the high end will remain NMC, probably 811 type of chemistries. The interesting thing is, which is less talked about, is in between what they call the volume market. That is what is called high manganese chemistry. So where part of the nickel and all the cobalt is replaced by manganese. So we have to see how this chemistry works out in the next few years. But I think this is a strong indication of the direction that battery chemistry is going. And they re-emphasized the development to solid-state batteries, which we currently expect to be in full swing by 2030, but not that much before. But again, looking at how fast things are going, even there could be some surprise. But time will tell, of course. Yeah. That was really some, I thought, interesting developments I wanted to share with you. I will hand over to Philippe for closing of the webinar. And as said before, I really invite you to be present in tomorrow's webinar as well. Thank you very much.
Thank you very much, Bert. Thank you for sharing this insight. We indeed thank you all attendees of today for following up the webinar from this topic. There is also tomorrow a webinar also organized with the critical raw material for EV, or CRM for EV, together with Bert Witkamp, on focus on Western Australia. We really look to the raw materials related to the battery topic. And of course, the upcoming AVERE webinars in April and May, respectively, the clear and NOx emissions for vehicles and on the Graphite. Thank you very much. We will see if your questions still can be answered by written, and look forward to see you in one of our next webinars. Goodbye.
Bye-bye. Bye-bye to all. Thank you.